Okay, the homework from page 539 and then from 552. So there were 4 and 539, and the first one, they all say to assume the direction of the moving particle was perpendicular to the magnetic field. In other words, all the sine thetas are 90. So the first question says, protons pass without deflection through a 0.6 Tesla magnetic field balanced by a 4.5 times 10 to the third Newton per Coulomb electric field. What is the speed? So for all of these guys, there's really two equations that we're going to use. And the first one is E is equal to VB. And so this one wants V, so V is equal to E over B. So not very complicated. It's just going to be 4.5 times 10 to the third newtons per coulomb over 0.6 of a Tesla. And so, let's see, 3 goes into both of those, that'll be 15 over 2, so it's going to be 7.5, right, to the something. You're not here to tell me what the something is, so I guess I have to do it, to the third. So V is equal to 7,500 meters per second. Alright, the second one, it's a proton again, moving at a speed of 7.5 times 10 to the third. Seems like I just found that. Should have read the next question. I wouldn't have done the work. As it passes through a 0.6 Tesla magnetic field, find the radius of the circular path. So this time we're going to use R is equal to mv over qb. Mass of a proton, in case you don't remember it, is 1.673 times 10 to the negative 27 kilograms. Velocity was at 7,500 meters per second. Charge of a proton, same as the charge of an electron, 1.602 times 10 to the negative 19 coulombs. And our magnetic field is 0.6 Teslas. Okay, and so 7,500 times 1.673 to the negative 27, and then you're going to divide that by 1.602 to the negative 19, except I missed the 1, shoot. 1.602 to the negative 19, and then you're going to divide that by 0.6. I don't know that I trust this because I screwed up typing it in, but it might be 1.3054 times 10 to the negative 4, but I'm going to check it again. 1.673 to 1.673 to the negative 27 times 7,500 divided by 1.602 to the negative 19, and then by 0.6. Oh, I was right. 1.3054 times 10 to the negative 4, and that should be meters. Alright, number 3. Electrons move through a 6 to the negative 2 Tesla magnetic field balanced by a 3 times 10 to the 3 Newton per Coulomb electric field. What is the speed? So again, E equals VB, so V equals E divided by B. So it's going to be 3 to the third newtons per coulomb divided by 6 to the negative 2 Teslas. So we definitely should get 0.5. Yeah, maybe just 0.5. I was going to say 0.5 to the something. Oh, maybe, but that's negative 2. Sorry, I can't even make up my own writing. 3 to the third divided by 6 to the negative 2, so it's going to be to the fifth, right? Fourth. Oops, yeah, because it's 0.5 to the fifth. So 5 times 10 to the 4th meters per second. And then the last one, calculate the radius for this guy. So again, R is going to equal mv over qv. And this time it's an electron. So 9.109 times 10 to the negative 31 kilograms. The V is 5 to the 4th meters per second. The Q, 1.602 to the negative 19 coulombs. And the B was 6 to the negative 2 Teslas. So all pretty simple, definitely straightforward, nothing nothing tricky or anything about these. So 0, 9, except maybe punching it in your calculator. Times 5 to the 4th, and then divide by 1.602 to the negative 19, except I just screwed that up. 1.602 to the negative 19, and by 6 to the negative 2. And so you get 4.738 times 10. 4.738 times 10 to the negative 6 meters. Alright, that's it for that page. So then we flip pages and we go over to 552. And the first question on 552 wants you to find the speed. So it tells you the electric field and magnetic field are crossed. One is 6 to the 5th, the other is 3 to the 3rd. Find the speed. We've already done this. So E is equal to VB. V is equal to E over B. So E was 6 times 10 to the 5th newtons per coulomb divided by 3 to the negative 3. So it's going to be 2 to the 8th. V is equal 2 to the 8th meters per second. Simple. Number 2, electrons moving 3.6 times 10 to the 4th meters per second pass through an electric field 5.8 to the 3 newtons per coulomb. What is B? Ooh, exciting. I get to rearrange it differently. E is equal to VB, so B is equal to E over V. I'm so excited I can hardly cope. So 5.8 to the 3rd newtons per coulomb, and that's going to be divided by 3.6 to the 4th meters per second. 5.8 divided by 3.6. So you get 0.1611 maybe? 0.1611, etc. Teslas. Kind of looks like the one's repeating. All right, number 3, electron beam moving 2.8 to the 5th in an electric field. What is the value of the magnetic field? Exactly the same question, just different numbers. So again, E equals VB, B is equal to E over V. So we have 1.4 to the 4th newtons per coulomb, and that's going to be over 2.8. So you're going to get a half to the negative 4, which means it's going to be 5 to the negative 5, I believe, Teslas. All right, number 4. There we go. Number 4, this time it wants you to find the radius. It gives you the magnetic field, it gives you, it wants you to find the speed. It gives you the magnetic field, the radius, the mass, the charge. So you're going to use R is equal to mv over qb, rearrange for v. So v is going to be equal to r qb over m. So V is going to be equal to R is 0.2